Exploration techniques. Exploration usually begins with low-impact operations, including desktop testing and field inspections to assess if signs of minerals or petroleum are present. It is achieved before more intensive and expensive technologies such as geochemical sampling, exploration, and geophysical surveys are carried out. There are 4 types of exploration techniques, including geophysical surveys, geological mapping, desktop surveys, and geochemical survey. Under geophysical surveys are airborne geophysical surveys, ground-based surveys, magnetic geophysical surveys, radiometric geophysical surveys, gravity surveys, electromagnetic surveys, seismic surveys, induced polarization surveys, and drill hole surveys. Under geochemical survey are soil sampling, stream sediment sampling, rock chip sampling, channel sampling, costaining or trench sampling, and bulk sampling. Geophysical surveys may help in the development of resources without the need for sampling, and they are normally carried out with minimum surface disturbance. Different kinds of geophysical surveys use different applications and facilities to measure different physical properties of the Earth. Geophysical surveys may be carried out on the ground or from the air. Airborne geophysical surveys, magnetic, radiometric, gravitational, and electromagnetic surveys are examples of airborne geophysical surveys. Low-flying helicopters or light airplanes fly in a grid pattern with measuring instruments mounted on the aircraft or towed underneath or behind. Ground-based surveys, seismic, magnetic, radiometric, gravitational, and electromagnetic surveys are examples of ground-based geophysical surveys. A survey can range from a single geophysicist or a team of geophysicists and technicians walking the survey area to the use of quad bikes, light cars, or seismic trucks depending on the type of survey. Magnetic geophysical surveys. Magnetic surveys are used to track changes in the Earth's magnetic field caused by magnetic minerals. These surveys are delicate enough to pick up on small changes in the amount of magnetic minerals present. They're used to analyze rock types and geological formations, and they can also help with resource identification. These surveys are routinely carried out by a geophysical technician on foot with a magnetometer and a sensor on a pole, or by a low-altitude aircraft or helicopter survey. They are most commonly used in metallic mineral exploration. Radiometric geophysical surveys. Radiometric surveys measure gamma rays which are constantly emitted from the Earth as a result of the decomposition of some commonly found radiogenic minerals. Most gamma rays originate in the top 30 centimeters of rock or soil, which can be detected using airborne surveys or a handheld spectrometer on surface rocks, which is a device that measures gamma rays. Gravity surveys. To quantify changes in rock density in the Earth's crust, a gravimeter measures the gravity field. These surveys are sensitive enough to detect minute changes in the field, and they can understand and map the locations of various rocks or geological formations with varying densities. In order to conduct ground-based gravity surveys, a geophysical technician must take gravity measurements at predetermined distance intervals and record the exact height at each location. Electromagnetic surveys. Electromagnetic surveys generate an electromagnetic field and measure changes in conductivity in the near-surface soil and rock in 3 dimensions. Variations in conductivity can be used to detect metallic minerals as well as to learn more about groundwater and salinity. A small crew uses transmitting and receiver cables to take ground readings. Seismic surveys. Seismic surveys track vibration as it travels across the Earth's crust. Seismology fundamentals are used in ground-based seismic surveys to make a picture of the geology underneath the surface. Seismic surveys are especially well-suited to flat-lying sedimentary basins because they can provide information about rocks down to several kilometers in depth. They are most commonly used in the exploration of petroleum and coal. Induced polarization surveys. IP surveys establish an electric field in the ground and measure the chargeability and resistivity of the region beneath the surface of the Earth. The method can be used to detect differences in resistivity caused by aquifers, metallic minerals, and other rock types. A small field crew uses transmitting and receiver wires to take readings. Drill hole surveys. Drill hole surveys entail the use of a thin wire rope to lower a variety of scientific instruments down exploration drill holes or boreholes. These sondas may measure rock properties such as density, porosity, and strength by measuring magnetic, radiometric, or electrical information from the rocks inside the borehole. This type of survey is commonly used in the exploration of petroleum and coal. Geological mapping. Geological mapping is the process of locating and identifying rock types and geological structures in relation to landforms and topography. It is sometimes the first method of exploration used on the ground, and it may take place at a local comprehensive scale or a regional scale. A geologist will frequently visit the region of interest to look at rock outcrops and observe the location, orientation, and features of the rocks or sediments visible at the surface. It may include gaining access to a property with a light vehicle, taking measurements, and collecting small samples from rock outcrops, soils, or streams for chemical analysis. This data will then be used to create a geological map of the exploration region, which will show the distribution of rock types and structures. Desktop surveys. Desktop surveys entail studying available geological information for a particular area of interest. This may entail investigating and analyzing previous company exploration reports, exploration data, and published geological information. This procedure enables an exploration company or prospector to make an informed decision prior to applying for a license or beginning real field work. Geochemical surveys. Geochemical surveys are used to identify areas for further investigation. Soil, rock, and/or sediment samples are typically collected as part of the surveys. These samples are sent to a laboratory for analysis in order to determine prospective mineralization zones. Soil sampling. To retrieve soil and subsoil samples, hand tools such as shovels, picks, and hand augers are used. Samples are frequently collected on a regular grid pattern and consist of small soil samples. Hand-operated or vehicle-mounted power augers may also be used. Following sampling, holes excavated during the program are routinely backfilled and vegetation replaced. Stream sediment sampling. Within drainage pipes, 2 kg samples of sediment are gathered. 3 samples are typically collected where 2 quicks meet, 1 downstream and 2 upstream of the meeting point in each of the merging drainage lines. Hand tools are commonly used to gather samples, which may be sieved during collection. Rock chip sampling. Handheld tools are used to haul up to a few tons of rock material from outcrops. During geological mapping programs, rock chip samples are typically gathered. Channel sampling. A series of soil or rock samples are gathered along the excavation's face. This may be a road cut, the face of an existing open pit or underground mine, a trench, or something else. Costaining or trench sampling. Costaining, also known as trench sampling, is a type of geochemical sampling that involves digging a shallow trench and mapping, analyzing, and sampling the exposed rock. It entails digging a costine or trench with a backhoe or other comparable equipment. The trench should be 20 cm wide to more than a meter wide and a few centimeters to meters deep, where hard rock is near the surface. Bulk sampling. Extraction of a bulk sample traditionally entails the construction of a small open-cut mine or the excavation of a small underground operation. The level of disturbance caused by a bulk sample is determined by the nature and location of the mineral deposit being sampled.